welcome to the deep dive.
Yeah.
So, I want you to picture this. You're walking down a busy street, or maybe, I don't know, you're sitting in a crowded coffee shop. Just look around.
Yeah, because statistically speaking, roughly 1 in 8 of the adults you see has taken an antidepressant.
1 in 8. I mean, that is just a staggering number when you really pause to think about it.
It really is. We're talking about a massive portion of the population interacting with a daily medication that, directly alters their neurochemistry.
Right. Which is exactly our mission for today's deep dive. We are going to unpack SSRIs, or selective serotonin reuptake inhibitors, which are still the first-line pharmacological treatments for major depressive disorder.
Absolutely.
We're going to explore exactly how they raise serotonin in the brain, dig into their surprisingly weird side effects, and look at their fascinating origin story.
And we also need to talk about that massive scientific reckoning recently that basically upended decades of public understanding.
Oh, definitely. Because to truly grasp the impact of these medications, you have to connect the dots between the microscopic pharmacology happening in our cells and the very real, often very messy, real-world impact they have on millions of lives.
Exactly. But to understand all the controversies and the history, we really have to start with the mechanics.
Right. Like, how does an SSRI actually work in the brain?
Well, we need to start from first principles, right at the microscopic level of the synapse. So imagine a tiny fluid-filled gap between the two neurons.
Okay, got it.
When the first neuron, the presynaptic serotonergic neuron, fires, it manufactures serotonin from an amino acid in your diet called tryptophan.
Oh, right, the turkey chemical.
Yeah, exactly. So it releases the serotonin into that gap, which we call the synaptic cleft. The serotonin floats across, hits the receptors on the second neuron, and triggers a chemical signal.
But, I mean, you can't just leave that serotonin floating there forever, right?
No, you really can't. The signal needs to be terminated.
Otherwise, the alarm bell just keeps ringing endlessly, and the system would be completely overwhelmed.
Precisely. So under normal conditions, the first neuron has a specialized transmembrane protein called the serotonin transporter, or SERT for short.
SERT, okay.
Yeah, and SERT acts like a highly efficient molecular vacuum cleaner. It uses the energy of a sodium ion gradient to physically suck the serotonin molecules back out of the gap and into the original neuron.
So they can be, like, repackaged and recycled.
Exactly.
Yeah.
And that is the reuptake part of the SSRI name.
Okay, let's unpack this for a second. So SERT is basically a molecular Roomba cleaning up the synapse, and the SSRI is like...
A sock.
Yes, a sock that gets stuck in the suction port, leaving all the dirt, or I guess the serotonin, out on the floor.
That is actually a remarkably accurate way to visualize it. Synthetic molecules like fluoxetine or sertraline are shaped just closely enough to actual serotonin that they wedge themselves perfectly into SERT's binding site.
Wow, so they just jam the machinery entirely.
They do. They don't get sucked up themselves, but they block anything else from getting through that channel. And this action happens incredibly fast.
How fast are we talking?
Within hours of taking your very first dose, SERT is substantially blocked. And the levels of serotonin sitting in that synaptic cleft measurably rise.
But wait, if they're selective serotonin reuptake inhibitors, the implication is that they only jam the serotonin Roompas. Is that actually true?
Well, no, not quite. The word selective is doing a lot more heavy lifting for pharmaceutical marketing than it is for actual neuropharmacology.
Really? So what else are they hitting?
Even at standard clinical doses, a drug like paroxetine also meaningfully inhibits the reuptake of another neurotransmitter called norepinephrine. And more troublingly, it blocks muscarinic acetylcholine receptors.
Muscarinic, what now? For those of us without pharmacology degrees, what does that actually mean for the patient?
It means the drug is interrupting the signals for basic bodily functions. Acetylcholine is crucial for your autonomic nervous system.
Oh, so the involuntary stuff.
Right. So when you block those receptors, patients experience off-target effects like severe dry mouth, blurred vision, or constipation. And sertraline, on the other hand, can actually bind to dopamine transporters at higher doses.
So they're absolutely not pure single-target magic bullets. They're messy.
They are only considered selective when you compare them to the older, much messier drugs that came before them in the mid-20th century.
Right.
But setting the older drugs aside for a moment, this rapid mechanical action creates one of the most fundamental paradoxes in modern psychiatry.
The timeline gap. Yes, this is the part that has always baffled me.
Exactly.
Because if the physical suction port is blocked and serotonin rises in the brain within a matter of hours, why do doctors tell patients that it's going to take 4 to 6 weeks to actually feel any relief from their depression?
It's a great question.
I mean, if it was just a matter of raising serotonin levels, you should logically feel better by dinner time on day 1.
And yet don't. That 4 to 6 week delay is known clinically as the therapeutic lag. And it proves definitively that simply raising serotonin is not what cures depression.
Huh. So the acute pharmacological action, the jamming in the vacuum, happens on day 1, but the actual clinical antidepressant effect takes a full month.
Right.
So what on earth is the brain doing for those 4 weeks? I mean, it can't just be sitting there doing nothing.
It is aggressively adapting to this new chemical environment, specifically through a process called receptor desensitization.
Okay, walk me through that.
When you chronically elevate synaptic serotonin by blocking that vacuum, the brain immediately notices the excess. It possesses these presynaptic autoreceptors, specifically the 5-HT1A autoreceptors.
The brain's internal brakes.
Yes, think of them exactly like brakes. They detect all this extra serotonin and tell the neuron, hey, there's plenty of serotonin out here in the gap, stop firing so much.
Which makes sense biologically. The brain is desperately trying to maintain its status quo, its homeostasis. It's fighting the drug.
It fights it vigorously. But if a patient keeps taking the SSRI day after day, week after week, those autoreceptors are constantly bombarded by the elevated serotonin.
So they eventually just give up.
Basically, yes. They fatigue. They undergo a process called downregulation, which literally means the neuron pulls those receptors away from the cell surface.
The brakes are physically removed.
Exactly. And once those brakes loosen, the serotonergic neurons start firing much more robustly. This is where the magic happens, because it triggers a slow cascade of downstream neuroplasticity.
Neuroplasticity.
Yeah.
Meaning the brain is actually changing its physical structure.
Yes. We see a significantly increased expression of something called BDNF, or brain-derived neurotrophic factor. You can think of BDNF as fertilizer or miracle grow for the brain.
Miracle grow for the brain. I love that.
Yeah, in animal studies, and this is supported by human imaging too, this cascade leads to measurable increases in synaptic connections and even the birth of brand new brain cells.
Wait, neurogenesis? Like new cells?
Yes, specifically in the hippocampus.
Here's where it gets really interesting. Because the hippocampus is the brain's center for emotion and memory, right? And we know that chronic severe depression actually causes the hippocampus to physically shrink.
Right.
So treating depression with an SSRI isn't like taking an aspirin for a headache. It's not topping off a low tank of gas. It's more like putting the brain in physical therapy so it can structurally rewire itself over time.
You've just articulated a massive paradigm shift in how neuroscientists view these drugs.
Really?
Yes. The medications appear to work by helping the brain structuralize and heal its own degraded networks, not by instantly fixing some transient chemical deficit.
And that reality completely contradicts the most famous, deeply entrenched story ever told about depression.
The chemical imbalance theory.
Right. The pervasive idea that you were depressed simply because your brain didn't naturally make enough serotonin. And, this daily pill just replaces what you're missing, exactly like a diabetic taking insulin.
That analogy was used for decades. Which brings us to a massive scientific reckoning.
Oh, the 2022 review.
Yes. In 2022, psychiatrist Joanna Moncrief and her colleagues published a sprawling umbrella review in the prestigious journal Molecular Psychiatry. They surveyed decades of rigorous research.
We're talking blood serotonin levels, receptor studies, genetics.
Postmortem brain analyses, absolutely everything they could find.
I remember when this dropped because the findings were just explosive. They concluded that there's no consistent evidence that depression is caused by lowered serotonin activity or concentration. None.
Which sent shockwaves through the public, even though, frankly, many research psychiatrists had already suspected it for years.
It was just such a compelling, neat narrative to tell patients, wasn't it?
Exactly. But the underlying science just didn't support that simplistic, linear, causal link.
But wait, I know you're probably listening to this right now and thinking, if the low serotonin causal story is basically unproven, how is it possible that these drugs are still considered highly successful first-line treatments? Like, are they just elaborate placebos?
They are not just placebos, but this really highlights one of the strangest situations in modern medicine.
How so?
We have a wildly successful drug class whose original, publicly marketed justifying theory has substantially eroded out from under it. But we have to separate two concepts here. Clinical efficacy, whether a drug helps a patient, and the mechanism of disease, why a patient is sick in the first place.
Right, which is like the old joke about Tylenol. Acetaminophen cures a headache, but a headache isn't caused by a biological acetaminophen deficiency.
That is the perfect way to look at it. SSRIs do raise serotonin, and that artificial elevation does trigger that downstream neuroplasticity and hippocampal cell growth we talked about.
Which does alleviate the symptoms of depression for a lot of people.
Yes, it does. But the initial causal chain, the idea that a natural drop in serotonin is what triggered the depression to begin with, was a myth.
Which honestly makes me wonder how we ended up with this specific chemical intervention in the first place. I mean, if they weren't designed to fix a proven chemical imbalance, how did we even get here? Were scientists just throwing chemicals at the wall in the 1970s to see what stuck?
It was slightly more calculated than that, and for the origin, we have to look back to a brilliant Swedish pharmacologist named Arvid Carlsson. He actually won a Nobel Prize in 2000 for his broader work mapping how neurotransmitters function. But back in the 1970s, he and his team were trying to isolate the therapeutic effects of older antidepressants without their terrible side effects.
What did they come up with?
They developed a targeted drug called zimelidine. It launched in Europe in 1982 and is generally considered the very first SSRI brought to market.
1982. But nobody today goes to the pharmacy to pick up a prescription for zimelidine. So what happened?
It is a tragic footnote in pharmacological history, honestly. Zimelidine was aggressively withdrawn from the market within about a year.
Why?
Because it was linked to Guillain-Barré syndrome.
Oh, wow. That's the rare autoimmune condition, right? Where the immune system gets confused and starts attacking the body's own peripheral nerves, causing paralysis.
Yes, exactly. It's a severe off-target immune response. You see, when you introduce a novel synthetic molecule into the human body, sometimes the immune system reacts unpredictably.
That's terrifying.
It is. So Carlson is the intellectual father of the SSRI mechanism, but his specific drug failed commercially due to these catastrophic safety issues.
Leaving the door wide open for an American pharmaceutical giant to step in and perfect the formula.
Enter Eli Lilly. Back in 1972, their chemists had synthesized a molecule called fluoxetine.
Okay.
And by 1974, they proved it selectively inhibited serotonin reuptake in rat brains without messing too much with dopamine or norepinephrine.
So avoiding the issues that plagued Carlson's compound.
Right. It finally secured FDA approval in late 1987 and launched in 1988 under a brand name that changed the world.
Prozac.
Prozac.
Prozac was absolutely everywhere. I mean, it became a cultural phenomenon almost overnight. Peter Kramer wrote that massive bestseller in 1993, Listening to Prozac, where he actually coined the phrase cosmetic psychopharmacology.
Yes, people were seriously debating if we were treating a biological illness or just fundamentally reshaping people's personalities to be better than well.
But I've always wondered about the clinical data from that era. Did Prozac take over the world because it was vastly better at curing depression than the old drugs?
Honestly, no. Drug for drug, Prozac was not necessarily more effective than the older classes of antidepressants like the tricyclics or the MAOIs.
Really? So why the explosion in popularity?
It conquered the global market because it was infinitely safer for the patient to consume.
Safer, meaning less lethal. Because those older drugs were incredibly dangerous, right?
Yeah.
From my understanding, tricyclic antidepressants, or TCAs, were highly cardiotoxic. They were notoriously lethal in an overdose situation.
They were, which creates an agonizing paradox for a psychiatrist.
I can imagine.
Think about it. If you are a doctor prescribing medication to a severely depressed, potentially suicidal patient, handing them a standard 2-week supply of a TCA was literally giving them the chemical means to end their own life if they took the bottle all at once.
That is a terrifying bind for a medical professional to be in. Just trading one massive risk for another.
And the other older class, MAOIs, came with their own nightmares. They required unbelievably strict dietary restrictions.
Oh, the cheese thing.
Yes, the cheese effect. Patients couldn't eat aged cheese, cured meats, or drink certain wines, or they would suffer a sudden, massive hypertensive crisis that could easily cause a fatal stroke.
So when Prozac arrived, it didn't have the cheese effect, and it was incredibly difficult to fatally overdose on.
Exactly. It won the market entirely on the back of safety and tolerability, not because it was some more powerful cure.
Okay, but speaking of cures, I was looking at the results of the famous STARD trial regarding how well these drugs actually work for people today, and the numbers were shocking.
They are sobering, yes.
The cultural myth is, take a pill, feel better. But in reality, out of 4,000 real-world patients taking a standard SSRI citalopram, I think only about 28 to 33% actually achieved full remission of their depression right away. Why is that number so incredibly low for a first-line drug?
Well, the STARD trial, which was published in 2006 and funded by the NMH, was a watershed moment because it stripped away the sterile conditions of industry-funded trials.
Right. These weren't hand-picked participants.
No, these were real-world patients with all the messy complexities of normal life comorbidities, varying life circumstances. And it showed us that for a massive portion of the population, the first SSRI simply does not work.
So what did they do with the 70% of people who didn't get better?
They moved them to a second step, either switching to a different drug or augmenting the SSRI with a secondary medication. And after up to 4 sequential grueling treatment steps, the cumulative remission rate finally rose to about 67%.
But each new step had diminishing returns, right?
Yeah.
And the relapse rates for those who took longer to remit were alarmingly high.
They were.
Which totally shatters that take a pill, feel better narrative. It's highly individual, trial and error medicine. You might have to endure trying 3 different medications over 6 months, dealing with side effects the whole time, just to find one that aligns with your specific biology.
And this profound messiness has fueled fierce, ongoing debates within the scientific community. For example, psychologist Irving Kirsch famously used the Freedom of Information Act to uncover unpublished negative clinical trials from pharmaceutical companies.
Oh, the file drawer problem.
Exactly. He argued that when you include the trials the drug companies intentionally hid in their file drawers, the actual effect size of SSRIs over a sugar pill placebo is surprisingly small, especially for mild to moderate depression.
Though, to be fair to the pharmacology, newer, more comprehensive reviews, like the massive 2018 Cipriani meta-analysis in The Lancet, did analyze all that data and confirm that SSRIs definitively outperform placebos across the board.
That's true. The effect might be modest in some cases, but it is statistically real. They do work.
But there's always a complex risk-benefit analysis at play, right?
Always. For instance, we haven't even touched on the 2004 FDA black box warning. The FDA analyzed the data and noted a statistically significant increased risk of suicidal thinking and behavior in patients under the age of 25.
Especially when they first start the drug or change doses, right?
Yes.
Which is just horrifying on a human level because you are taking the drug to treat the very condition that causes those feelings. It creates a massive debate in psychiatry regarding the risk of undertreating severe youth depression, which carries its own high mortality rate, versus the risk of overwarning and scaring parents away from a drug that could literally save their teenager's life.
It's a remarkably delicate balance, and it requires constant, vigilant monitoring by the prescribing physician during those first few vulnerable weeks.
So what does this all mean for the patient? You mentioned the trial and error process often involves dealing with side effects, and that actually brings up a huge misconception about these drugs.
Okay, let's hear it.
If we're taking a pill to fix a brain chemical, why is the primary side effect for so many people an intensely upset stomach? Let's do a gut check here. Where is most of our serotonin actually located?
This is one of the most fascinating aspects of human biology, and it always surprises people. Roughly 90 to 95% of the serotonin in your body isn't in your central nervous system at all.
95%.
Yes, it is produced and stored in your gut.
Oh, wow.
It's manufactured by specialized enterochromaffin cells lining your gastrointestinal tract, and its main evolutionary job down there is to regulate intestinal motility.
Meaning it physically helps push food through your digestive system.
Exactly.
Which perfectly explains the nausea.
You take a pill hoping to lift your mood, but that pill is systemic. It travels everywhere, including your stomach, where it just floods the local serotonin receptors.
Exactly right.
Learning that serotonin is largely a digestive chemical completely reframes our societal understanding of mood chemicals. It really does, and it highlights why you have to be extremely careful with systemic drug interactions. Because serotonin is utilized all over the body, you can trigger a rare but life-threatening condition called serotonin syndrome.
Okay, what is that?
It occurs when your body accumulates a toxic, overwhelming excess of serotonin, leading to severe agitation, hyperthermia, and dangerous muscle rigidity.
How does someone accidentally trigger that?
Usually by combining an SSRI with other medications or supplements that also affect the serotonin system. That could mean mixing them with those older MAOIs or certain migraine medications called triptans, or even taking high doses of over-the-counter herbal supplements like St. John's wort.
Wait, really? So even a supposedly safe natural supplement bought at the grocery store can trigger a fatal interaction if you were on an SSRI?
Absolutely. The chemical source doesn't matter to your receptors, only the mechanism matters. And this systemic impact also explains another major misconception regarding how you stop taking them.
Oh, the withdrawal.
Well, we call it discontinuation syndrome. Because SSRIs are not considered controlled substances, meaning they don't get you high and you don't build an addictive craving for them, many people assume you can just toss the bottle in the trash when you feel better and quit cold turkey.
I imagine the brain's downregulated autoreceptors do not react well to that sudden drop.
They react violently. Because the brain has structurally adapted to the high serotonin environment, pulling the rug out causes intense dizziness, flu-like malaise, severe irritability, and a very strange neurological phenomenon patients describe as brain zaps.
Brain zaps, that sounds awful.
Yes, patients report feeling a sudden, brief electrical shock inside their head, often triggered just by moving their eyes side to side.
Wow.
It is incredibly uncomfortable, though not inherently dangerous. It's especially common with drugs that have a very short half-life, meaning they are metabolized and leave your system very quickly, like paroxetine.
Whereas a drug like fluoxetine or Prozac has such a remarkably long half-life that it practically tapers itself out of your bloodstream over a matter of weeks, sort of cushioning the blow.
Right. But standard clinical practice dictates that doctors will almost always prescribe a slow, deliberate taper to safely transition a patient off an SSRI.
Which really underscores the overarching theme here. The brain requires time to adapt, whether you are starting the medication or stopping it.
Exactly.
Okay, let's bring this all together. SSRIs are an undeniable triumph of safer psychopharmacology compared to the lethal side effects of the drugs that came before them.
Absolutely.
They are microscopic mechanical marvels that wedge themselves into the CERT vacuum like a sock in a Roomba, serving as the necessary catalysts for slow structural brain rewiring and neuroplasticity.
Well said.
But their foundational public myth, the simple, heavily marketed chemical imbalance narrative, has basically crumbled under the weight of modern scientific scrutiny. And finding the right fit for an individual remains a messy, highly individualized trial and error journey full of gut-level side effects.
And this evolution of understanding matters deeply because, as we noted at the very beginning, 1 in 8 adults takes these medications.
Yeah, that statistic is just wild.
This is not just niche science buried in a medical textbook. This is a live, very public case study in how medical explanations evolve over time. It fundamentally changes how doctors and patients must navigate the murky waters of informed consent when the underlying science of why a drug works is still settling, even when the clinical data proves that it works.
It really is a testament to how infinitely complex our neurobiology is. Which leaves me with a final thought for you to mull over as you go about your day. If our primary pharmaceutical treatment for depression ultimately works by triggering slow structural neuroplasticity over weeks and months, rather than just instantly fixing a neat chemical deficit, how much of what we call healing is actually just the drug giving the brain the biological flexibility it needs to heal itself?